Right now, the most valuable substance on Earth isn't buried under desert sands or locked in underground vaults. It's a fingernail-sized piece of silicon that powers everything from your smartphone to fighter jets. And nations are fighting over it like they once fought over oil fields. What if I told you that this tiny object could decide who wins the next world war? Semiconductors, the silicon chips that run computers and electronics, have become the 21st century's most strategic resource. For decades, they were just another tech component, but between 2018 and 2025, they transformed into weapons of economic warfare, national security priorities, and the center of a geopolitical storm involving the United States, China, Taiwan, and the Netherlands. The stakes are simple. Whoever controls the semiconductor supply chain controls the future of artificial intelligence, military technology, and the global economy itself. This matters now because the world's most advanced chips, the ones running AI systems and supercomputers, can only be made in a few places on Earth. Taiwan produces over 60% of all semiconductors and over 90% of the most advanced ones. One company, TSMC in Taiwan, is the sole manufacturer of the cutting-edge chips that power everything from iPhones to F-35 fighter jets. If that supply disappeared tomorrow, the global economy would face what experts call an immediate, catastrophic collapse. The chip war didn't start with a bang. It started with a trade dispute. In 2018, the United States placed tariffs on Chinese goods, and China retaliated by announcing a national plan to become self-sufficient in semiconductor production by 2025. American officials realized that China was stockpiling chips and investing hundreds of billions in domestic production. Then came the hammer. In October 2022, the Biden administration announced the most aggressive export controls in modern history, banning American companies from selling advanced chips and chip-making equipment to China. The rules didn't just block chip sales. They prohibited American citizens from working in Chinese semiconductor facilities, and banned any chip made anywhere in the world with American technology from reaching Chinese companies. It was economic warfare through technology. China called the move technological terrorism and vowed to accelerate its own chip development. But there was a problem. Making advanced semiconductors requires machines that cost over $150 million each, and only one company in the world makes them, ASML, a Dutch firm. In 2023, under pressure from Washington, Netherlands agreed to restrict ASML sales to China, cutting off Beijing's access to the extreme ultraviolet lithography machines needed for cutting-edge chips. By 2024, the semiconductor battle lines were clear. America had convinced Japan and South Korea, to other chip-making powers, to join the export. China responded by restricting exports of gallium and germanium, rare materials essential for semiconductor production. Taiwan, meanwhile, found itself in the most precarious position on Earth, holding the chips the whole world needed, while sitting just 100 miles from mainland China. In August 2024, reports emerged that China had made significant breakthroughs in 7-nanometer chip production, despite the sanctions, using older equipment and innovative techniques. American officials were reportedly shocked at how quickly Chinese engineers had found workarounds. The chip war was escalating, and the technological gap wasn't widening as planned. The foundation of this conflict rests on documented policy decisions and economic data. The October 2022 export controls were published in the Federal Register as a 139-page rule, covering semiconductors, supercomputing, and related technologies. These weren't vague sanctions. They included specific technical thresholds. Chips couldn't perform more than 300 trillion operations per second, and chip-making equipment couldn't produce features smaller than 14 nanometers. Investment figures tell the spending story. China's National Integrated Circuit Industry Investment Fund, known as the Big Fund, raised $47.5 billion in its third round of financing in 2024. The United States responded with the CHIPS Act, allocating $52 billion to domestic semiconductor production and research. Taiwan announced plans to spend $9 billion expanding TSMC's capacity. The money was real. The urgency was real. Corporate decisions provide another evidence layer. In 2023, Nvidia, the American AI chip giant, created a special China version of its advanced chips that technically complied with U.S. restrictions but still delivered significant computing power. The US government closed that loophole within months. Companies were caught between law and profit, trying to navigate an increasingly impossible middle ground. Physical evidence emerged from unexpected places. In December 2023, researchers at akin, a Canadian analysis firm, purchased a Huawei Mate 60 Pro smartphone and discovered it contained a 7-nanometer processor made by SMIC, China's leading chip maker. The chip shouldn't have been possible given the equipment restrictions, yet there it was, functioning inside a commercial product. The report was verified by multiple independent semiconductor experts. Not everyone agrees this is a war worth fighting. Some economists argue that export controls will ultimately fail because technology always finds a way to spread, and restrictions only incentivize faster Chinese innovation. They point to historical examples. When the US restricted GPS technology in the 1990s, Europe built Galileo and China built Beidou, their own satellite navigation systems. Industry voices are divided, because some American semiconductor executives privately told congressional committees that the restrictions would cost them billions in lost revenue while only delaying China by 2 to 3 years. Others insisted that maintaining the technology gap was essential for national security, even at significant economic cost. The debate often split along company lines. Those with major Chinese revenue opposed restrictions. Those focused on US military contracts supported them. There's genuine uncertainty about China's actual capabilities. Western intelligence assessments reportedly vary widely on whether Chinese chipmakers can mass-produce advanced semiconductors at competitive yields and costs. Some analysts believe China is 5 to 10 years behind. Others suggest the gap is closing to 2 to 3 years. The truth is obscured by corporate secrecy, national security classifications, and deliberate misinformation from all sides. Questions remain about Taiwan's position. Some experts argue that Taiwan's semiconductor dominance actually protects it, creating a silicon shield that makes invasion economically catastrophic for any aggressor. Others counter that this makes Taiwan an even more attractive target, offering whoever controls it an unmatched strategic asset. Both theories can't be fully tested without the very conflict everyone wants to avoid. Engineers and workers find themselves trapped in the middle of this technological Cold War. Hundreds of American chip experts who built careers working with Chinese companies have been forced to choose, keep their jobs and lose their US citizenship connections, or leave China and abandon years of professional relationships. These aren't abstract policy debates for them. They're mortgages, children's schools, and life plans appended by geopolitical forces beyond their control. Taiwanese families live with the weight of being the world's most valuable manufacturing hub and the world's most dangerous potential conflict zone. Parents in Hsinchu Science Park, Taiwan's Silicon Valley, send their children to school each morning, knowing their city would be a primary target in any military scenario. They're not just making chips. They're resitting on the economic equivalent of a nuclear stockpile that both sides are desperate to control or deny to the other. Thousands of Chinese graduate students studying semiconductor engineering in American universities face visa restrictions, search limitations, and suspicion from both governments. Young scientists who just want to advance technology find themselves characterized as potential spies or security threats. The human cost of technological competition includes dreams deferred and careers derailed by accidents of birthplace. Think of semiconductors like oil in the 20th century. Just as industrialized nations once needed oil for tanks, ships, and planes, they now need advanced chips for artificial intelligence, quantum computing, and autonomous weapons. Controlling the oil supply meant controlling military power. Controlling the chip supply means controlling the future of warfare, intelligence gathering, and economic competitiveness. The analogy is almost perfect. Both are essential resources. Both require massive infrastructure to produce, and both have turned geographic accidents into strategic choke points. But there's a crucial difference. Oil deposits are scattered worldwide. Can't easily move Saudi Arabia's wells to Texas. Advanced chip production, however, is knowledge-based and concentrated in a handful of facilities that could theoretically be replicated elsewhere, given enough time and money. The race isn't just about controlling existing production. It's about whether China can build its own supply before the US and allies can diversify away from Taiwan. It's a geopolitical clock running in real time. Broader stakes involve technological sovereignty. The idea that no nation can be truly independent if it relies on potential adversaries for critical technology. Europe learned this with Russian natural gas. Now the whole world is learning it with semiconductors. Historians will likely look back at the 2020s as the decade when global supply chains, optimized for efficiency and profit, collided with renewed nationalism and security concerns. Chips are just the most valuable, most visible battleground in that larger collision. Here's what we know for certain. Semiconductors have become strategic assets. Export controls are unprecedented in scope, and massive investments are flowing into domestic production across multiple countries. What we don't know is whether these restrictions will succeed in maintaining the technology gap, or whether they'll simply accelerate the world's division into competing technological blocks. Scenario 1. Export controls successfully slow Chinese advanced chip development, giving the US and allies 5 to 10 more years of technological advantage. TSMC completes new factories in Arizona and Japan by 2027 to 2028, reducing Taiwan's strategic vulnerability. China continues making progress, but remains a generation behind in the most advanced nodes. The chip war settles into a long-term technological competition without immediate crisis. Scenario 2. China achieves a major semiconductor breakthrough using alternative approaches, possibly through new materials or fundamentally different chip architectures. The world splits into two incompatible technology ecosystems, one American-led and one Chinese-led, forcing every country and company to choose sides. Global tech becomes like the Cold War space race with parallel development and minimal cooperation. Scenario 3. A military or political crisis over Taiwan erupts between 2025 to 2030, potentially triggered by factors beyond semiconductors. Chip supply becomes an immediate weapon. Taiwan threatens to destroy fabs rather than let them be captured, or production gets disrupted by conflict. Global electronics production crashes, causing economic chaos and accelerating desperate attempts to build production elsewhere. This is the nightmare scenario everyone is preparing for, but hoping to avoid. Scenario 4. Major powers eventually negotiate some form of technology sharing or mutual access agreement, recognizing that total technological divorce is too expensive and destabilizing. This would require significant political changes and trust building that currently seem unlikely but aren't impossible. International frameworks might emerge similar to nuclear non-proliferation treaties, governing who can access the most advanced chip-making technology and under what conditions. The most likely outcome is probably some hybrid partial technological decoupling, continued competition, occasional cooperation on specific issues, and constant maneuvering for advantage. The chip war won't end with a decisive victory. It'll become a permanent feature of 21st century geopolitics. The battle over semiconductors is fundamentally a battle over the future. Who gets to build it, who controls it, and whether that future will be shared or divided. Unlike oil wars that could be won by capturing territory, this conflict will be won by whoever can innovate faster, manufacture better, and convince more allies to join their technological ecosystem. The chips themselves are tiny, but the stakes have never been larger. If you want to understand the technology that makes these chips possible, subscribe to our channel and watch Inside ASML, the machine that makes the modern world to see the extraordinary engineering that sits at the center of this geopolitical storm. These aren't just trade disputes, they're the opening moves in a competition that will shape the rest of the century.